So it's great to be here. My name is Oscar. I'm a researcher at the Universidad del Valle de Guatemala. My research interests are around program transformation, programming education research, and recently online learning to rank. And generally my motivation, or sort of my interest as well, is what can we do to make programmers more efficient? And so today's talk is actually about, well, a different way of running Elasticsearch that I think can make programmers more efficient. So we're going to be talking about a Spark cluster with Elasticsearch, but we're going to be running it inside the driver node of our cluster. So here's our agenda. First, I'll start off with the problem statement. I'll give you a little bit of the motivation that led me to this talk. Then we're going to look into how we can use the ES Hadoop connector to read and write from an internal or external Elasticsearch server. Then we're going to create a local instance on our Spark cluster, so a local instance of Elasticsearch. We'll continue with taking a snapshot and restoring a snapshot onto S3. And then I'll finish off with a demo based on Holden Karau's streamlining search indexing using Elasticsearch and Spark. But in this case, we're going to be running Elasticsearch inside our cluster. And finally, I'll open up for Q&A. So this is a problem statement. It's something actually I came across when developing a Spark program that integrates with Elasticsearch. So I found that during development with this ES Hadoop connector, it is rather cumbersome to have Elasticsearch running outside the Spark cluster. So why cumbersome? Well, maybe developers might need to deal with opening up network ports or going through different sorts of permissions within the organization. Especially in a big organization, this might be difficult or cumbersome. And this happens whenever we have Elasticsearch running outside our cluster. So this is some sort of architecture, like a diagram that I'm going to use as a running example. Over by the bottom left here, you will see two S3 buckets. There we have a previously generated snapshot of Elasticsearch. We also have a CSV file. We're going to bring those over into our Spark cluster, which is running Elasticsearch inside the driver node. Then we're going to join both data sets and produce an index out of that. And that resulting index, we're going to take a snapshot of and store it once again on S3 over by the top here. And then, well, this is where, well, you'll notice there's a lot of snapshots here. And I think that that's an interesting coordination mechanism between teams just to exchange snapshots. So here you have, we might have as an example an Elasticsearch service. And we're going to maybe restore the resulting snapshot there. So coordination between teams, like here, for example, we might have an ops team and we might have a development team. So their work is very cleanly separated. And they're using snapshots as an interface. Now, sort of to synthesize here, this is the motivation for this talk. I think it's nice to have developers be able to control their own instance of Elasticsearch, and especially during development of an application, I see this as having value. So not only controlling, running, configuring different parameters, I think that's valuable to developers. But as well, reducing dependencies between teams, for example, using snapshots as an interface, I think that's also positive. And then, well, last but not least, increasing efficiency when doing QA, I think is also something that's of value here. So let's see what the ES Hadoop connector provides out of the box with Elasticsearch running inside our Spark cluster or outside. So first piece of functionality here is that it gives us an ability to write an RDD onto Elasticsearch, and that's very handy. So we have we're just needing to call a function, save to Elasticsearch, tell it what index we want to save the RDD to, and then, well, it saves it. Maybe one detail is that the data has to be set up in an appropriate way, so like key values, and then it saves it automatically to Elasticsearch. Elasticsearch can infer the data types, set up the mapping for us. It's all very convenient. Similarly, we're also able to read from Elasticsearch. Whether that Elasticsearch instance is running outside our cluster or inside, this is, well, very useful. We can read into an RDD, as shown here, content that's coming from an index. So all very nice and well up to now. But the issue is, well, coming back to the motivation, where exactly do you run Elasticsearch? And so some of the things you might run into are opening up ports, different complexities, coordination between teams. So why not run it inside our Spark cluster, and more specifically on the driver node? And I argue that at least for development purposes, this is, allows us to be very agile, very efficient as developers. So the next natural question is, well, okay, I'm convinced maybe it does increase development efficiency, but so how do you run Elasticsearch inside a Spark cluster? So first off, you need to import some libraries. Here I'm importing a few additional ones like Elastic4s, which is useful, provides a useful DSL for communicating with Elasticsearch. Also some Spark-specific libraries, and then libraries from Elasticsearch itself. Next, well, we set up an Elasticsearch server class, which we can configure with the parameters that we're used to, like the exact same parameters we can configure here. So like for example, I want to enable HTTP, I want it to bind to this specific IP address, I want the cluster to have a certain name. Also important, I want indexes to be auto-created so that I don't have to specify them sort of manually. And once that's done, well, we also have a couple of functions here to start and stop the server. Once that's done, we simply call server start, and we're going to have Elasticsearch running on our driver node. So now that it's running there, well, we can make use of the ES Hadoop connector in the same way that we would with an Elasticsearch server running outside our Spark cluster. So by simply calling save to Elasticsearch. So once we have an RDD in place, we can save it to our Elasticsearch instance. Similar to Elasticsearch running outside our cluster, well, we can do a get on this URL to, for example, get the indices that are currently on that Elasticsearch instance. And we could also do that, well, here we're doing it programmatically. We can also do it through a terminal, for example. But one detail there is that we would need to publish the IP address of the Elasticsearch driver node. And so on the demo I'm going to show, I've published that using an Elastic IP from Amazon. So that comes in really handy for this. So what else can we do? Well, we can take a snapshot. Snapshots are important in this talk. And we do that by, well, giving the usual parameters. So the access key, which I have changed here, as well as the secret key, what repository we're going to we're going to save our stuff into. What's the repository name? What type is it? Well, it's an S3 repository. And then we simply execute. And so we're going to save a snapshot into a specific repository. And you'll notice that there's .await here. That's in order to skip the futures functionality so that we're going to block until this completes execution. That's sort of a design choice here. Well, in addition, we can also restore from S3, which was also part of our example. Useful there is to first close the index. We're going to set up the parameters similar to the previous scenario. Maybe we need to create a repository. And then we execute restoring the snapshot. And here you'll notice that we're waiting an additional amount of time, especially with big indices. This might be the case. So I'm just telling it here, wait 1,000 seconds. Could be more, could be less. And now, well, I've prepared a demo of this. So I'm going to switch over here. So I've set up, let me make this a little bit bigger. So Elasticsearch is already running on the driver node of 2 Spark clusters that I've set up with Databricks. So if I do a telnet on port 9200, I'm going to, well, we see that it's running. So that's great. Next, I'm going to show you the notebook here that I used to, sort of the application, let's say, that's under development. It's actually a Twitter application, as I mentioned, based on Holden's stock from an earlier Spark Summit. So I set up the Twitter credentials here. I have 2 sets of credentials just in case I run into Twitter limitations with their API. Next is setting up the Elasticsearch server, which we saw on an earlier slide. We started. This has already been executed, so it's already running in the cloud. I've already published the internal IP address of the driver node using Elastic IP from AWS. So that's available now on the internet. That's already running, so I don't need to run it. The piece that's not running yet is this here. This is actually our application based on Holden stock. Basically what it does is it takes a tweet, it extracts the created at, so when was the tweet created, what's the source, document ID, a message, and hashtags. So we're going to be seeing hashtags coming in live from Twitter. This is streaming code, so we're going to see that live being indexed onto Elasticsearch. So before I run that, I just want to start Kibana because we're going to visualize this in Kibana. Oh, there we go. So Kibana should come up. Okay, there we go. Now I'm going to execute this. So it's running. Next, I'm going to switch over to Kibana here, which is running on port 5601. Oh yeah. There we go. Okay, so back to our application. We're saving here to an index called Twitter/tweets. So I'm going to give that as a name. We immediately see that there's a time-based field That's the created at. We're going to use that to order events by time. And here we see the mapping, which Elasticsearch automatically recognized for us. Everything's a string now, but we could change that if we wanted to. And we can go and visualize, for instance, using a line chart. We can visualize terms, specifically hashtags. And let's say we're interested in looking at the top 100 hashtags that are coming in live from Twitter. And there we go. If I refresh this, you'll see that it changes continuously because these tweets are being indexed live onto Elasticsearch, which we're reading with Kibana here. So that's up and running. I'm going to switch back to the application. Maybe cancel out of this. We've got some tweets in there. They've been indexed. So we can use something like what we also saw on a previous slide, checking the contents here programmatically. So we see that there's a Twitter index highlighted here. Maybe that's a bit small. There's a Twitter index that was created. It has a size of 2.7 megabytes. Apparently, around 6,500 tweets were indexed. So we can go ahead and take a snapshot of that. So first, I'm going to run this. Should have run. And now, well, we've taken a snapshot, I would expect. Oh, there we go. I think I need to execute this again. Oh, yeah. Oh, yeah, this is because I think it already existed. But anyway, the point is that when we go to S3, and I can show that with a previous snapshot, it created a folder for the index. And inside that folder, well, here we have our snapshot. And that's what we can use to give to another development team or to an operations team as our finished product. So that's sort of the flow of the example that I wanted to show. Now I'm going to switch back to the slides here. So what have we seen? Well, we've seen how to read and write from an internal or external Elasticsearch server. We saw how to create an Elasticsearch server inside our Spark cluster, specifically running inside the driver node. We saw how to take snapshots, restore snapshots of Elasticsearch indices on S3. And we saw a demo where tweets are being indexed live onto Elasticsearch, running inside our Spark cluster. Next steps, well, I think it'd be interesting to test this with Spark 2.0, also with continuous applications as proposed by Databricks. Might be interesting to index the results of stuff that's coming in by streaming or batch. And then also, since Elasticsearch 5 was recently released, it might be interesting also to test this with Elasticsearch 5. So those are next steps. And so now I'll open up for Q&A, but first I just wanted to thank my colleagues at Universidad del Valle, the students, and especially my colleagues Kyle, Pablo, and Eric. Thank you very much.
Okay, questions for Oscar? Okay.
You grabbed my seat there. So I saw the integration with Elasticsearch earlier, where you was writing RDDs into into Elasticsearch. Did you consider using data frames instead? It seems to be the theme of the conference so far.
Yeah, great question. I'm not sure really, to be honest, if the ES Hadoop connector supports data frames yet.
Okay.
So I haven't tested that.
More questions? Oh, great. Thank you.
Thank you for the talk. Just a question, trying to understand how this is going to scale if we wanted to, put quite a lot of data into Elasticsearch. You're running Elasticsearch just on the server, right? You're not running an Elasticsearch cluster. Is that correct?
Okay, great question. So the caveat here is that this is especially meant for developers. So, well, but could be that we want to scale during development. That actually is one reason why we're trying to escape from running stuff locally on our laptop. So one idea could be to also run Elasticsearch on the worker nodes. Maybe that could be interesting. But also, I was thinking earlier, well, might even be possible to run, to make the Elasticsearch instance that's running on the driver node. Why not have that, why not join that to an external Elasticsearch cluster? So that might also be a way to scale.
Any more questions? Anyone? Okay, that's great. Okay, thank you very much, Oscar. Thank you.
Thank you.